Pluto, a distant and confounding, more modest planet, was once a singular individual from our planetary group's planetary family. Anyway, later disturbing statements by driving astrophysicists Neil deGrasse Tyson and Michio Kaku brought Pluto back into the spotlight with a dazzling exposure. They propose that this chilly world is on a potential compressed lesson with Neptune. Yet how is it that this could work out? Also, what may be the results of such a colossal event? Are we seeing an interesting grandiose peculiarity? Or is there another thing to this approaching limitless accident? Go along with us as we examine the possible results of a Pluto-Neptune impact. Pluto, a past planet that was minimized to a smaller person planet halfway because of its interested circle, remains a subject of interest and study in the astronomical community. As per ongoing forecasts by driving specialists, Pluto's direction is unsafely near Neptune's. Driving astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising the admonition of a potentially hazardous accident between these two planets that could be an enormous danger to Earth. But how is such an event even possible? Pluto's venture around the Sun is not normal for any other planet in our close-by planetary framework. It requires a dazzling 248 years to finish a solitary circle. This implies that since its discovery in 1930, it hasn't even finished one full upset. Anyway, the interest doesn't stop there. Pluto's way is set apart by its profoundly curved shape, veering totally from the almost round circles of the significant planets. What makes Pluto's circle considerably more surprising is its tendency, determined at 17 degrees to the ecliptic plane. The way Pluto follows is much more extreme compared to the other planets. This tendency and unconventionality add layers of intricacy to its orbital pattern. Quite possibly of the most intriguing part of Pluto's circle is its intermingling with Neptune's. For something like 20 years in each circle, Pluto, in reality, moves nearer to the Sun than Neptune, opposing what we could anticipate from their situations in the planetary group. This prompts the normal inquiry: why hasn't Pluto slammed into Neptune? The answer lies in the gravitational impacts of different planets. The investigation of Pluto's circle began soon after its discovery. Initially, space experts battled to get a handle on its extraordinary way. In contrast to different planets, whose circles lie fairly close to the ecliptic plane, Pluto's circle stood apart with its precarious tendency and unpredictable shape. The secret extended with the acknowledgement that Pluto's circle, in all actuality, does for sure cross Neptune's. The steadiness of Pluto's circle amidst these intricacies is evidence of the complexities of divine mechanics. The three-body issue in space is about sorting out how three particles in space, like Pluto, Neptune, and the Sun, move and impact each other with their gravity. It's like attempting to anticipate where they will go in light of where they start and how they pull on each other. In Pluto's case, this issue shows how its way, Neptune's way, and the Sun's gravity all coordinate in a muddled manner. Terms like asymptotic libration, scope libration, and the VZK wavering are part of this riddle. As per astrophysicists, what's keeping all planets in their circles is a sort of libration. In regards to Pluto and Neptune, this term implies that at whatever point Pluto crosses Neptune's circle, its position is continuously something like 90 degrees away from Neptune. This spatial partition is significant in keeping their circles from impacting. Scope libration, on the other hand, alludes to the upward development of a divine body in its circle. For Pluto, this implies that when it comes nearest to Neptune, or some other monster planet, it is situated far over their orbital plane, contributing an additional layer of assurance from potential impacts. Another basic calculate what is going on is the VZK wavering. This is named after three scientists, VAV, Apple, and LV, who studied how things move in space. It's about how three space objects like Pluto, Neptune, and the Sun pull on each other with their gravity. This pulling impacts how they move, and for Pluto's situation, VZK assists us with understanding the reason why its way near the Sun is so unusual. In spite of the apparent bedlam, this swaying helps keep Pluto's circle stable for an exceptionally significant time frame. The VZK wavering shows that despite the fact that things in space might appear to be wild and arbitrary, certain examples and rules keep everything set up. These parts assist with keeping Pluto's circle stable, guaranteeing it doesn't slam into Neptune or stray off kilter. This three-body issue makes a difference in understanding how these circles change because of the manner in which space objects pull on one another. Focusing on this helps us learn more about Pluto, our nearby planet group, and far-off stars and planets. Numerical reenactments in the last part of the 1980s uncovered that regardless of these steady properties, Pluto's circle is really fierce, with minor deviations in beginning circumstances prompting massive contrasts over a long period of time. Anyway, these strange properties of Pluto's circle have been found to maintain steadiness over unbelievably significant timeframe scales. Effectively monitoring the disorder, later PC tests have assisted us with understanding how the monster planets like Neptune, Jupiter, and Saturn impact Pluto's circle around the Sun. Neptune has a special relationship with Pluto, where for each 2 circles Pluto makes around the Sun, Neptune makes 3. This reverberation helps keep Pluto's circle stable. Anyway, Neptune isn't the only one helping. Jupiter's gravity likewise plays a huge part in safeguarding Pluto's circle. What's more, Saturn helps in general as well. These tests show that Jupiter's gravity alone is sufficiently able to guarantee Pluto stays on a consistent way for an incredibly significant stretch, potentially even billions of years. Maybe Neptune, Jupiter, and Saturn are working together to guarantee Pluto can keep on moving securely in space without running into inconvenience. These idiosyncrasies are imperative in the bigger setting of the universe for keeping the control and consistency of divine bodies' development. Without these parts, the nearby planet group, as we probably are aware it, would be a position of far more prominent strife and eccentricism. Bodies like Pluto might actually slam into others or be launched out from their stable circles, prompting a cascading type of influence on other heavenly bodies. For Pluto, especially with conversations about it conceivably slamming into Neptune in the future, understanding its circle is fundamental. This gives us a more clear image of the nearby planet group's dynamic nature. The instance of Pluto outlines how, indeed, even the most apparently unsteady circles can accomplish a condition of equilibrium through the complicated cooperation of gravitational powers and orbital mechanics. It moreover shows the significance of steady perception and investigation of these peculiarities to more readily get a handle on our spot in the universe. Researching the profundities of space frequently drives us to stand up to the whimsical nature of divine bodies, and Pluto's circle is an ideal illustration of this flightiness. The idea of orbital turmoil, which alludes to the sensitive reliance of a divine body's circle on its underlying circumstances, is plainly delineated on account of Pluto. This implies that even slight varieties in the Bantam planet's position or speed can considerably change its drawn-out circle. Utilizing virtual recreations has been staggeringly useful for exploration to sort out how Pluto moves in space. These recreations use unpredictable math to imitate how Pluto, along with other space objects like Neptune, pull on each other. By changing little subtleties in the recreations, stargazers can perceive how even minuscule changes can make a large distinction in where Pluto winds up. In the late 1980s, these recreations showed something truly intriguing about Pluto's circle. Regardless of having systems like asymptotic and scope libration to keep it stable, its circle can in any case be wild and capricious. Assuming you start with even a small contrast in where Pluto is, or on the other hand how quick it's moving, over numerous years its way can wind up looking very unique. Anyway, in spite of this tumult, Pluto's circle stays stable for a long time, billions of years. This implies Pluto's excursion around the Sun has a sort of order to it, despite the fact that it appears out of control at first. Predicting enormous occasions, particularly when they include turbulent circles like Pluto, presents immense difficulties. The inborn capriciousness of these frameworks implies that drawn-out forecasts are frequently loaded up with vulnerabilities. While numerical reproductions give a solid device to comprehend and anticipate the future way of behaving of heavenly bodies, they likewise highlight the restrictions of our prescient abilities. These models rely intensely upon the precision of starting circumstances and the intricacy of the associations they reproduce. Any slight misstep or bending can prompt radically various results, making exact expectations an overwhelming undertaking. Moreover, the turbulent idea of heavenly circles like Pluto's reminds us of the always developing and dynamic nature of the universe. While we have made colossal steps in grasping space, the case of Pluto helps us to remember how our insight of the universe actually stays restricted. Understanding the gravitational impacts of the monster planets on Pluto's circle gives significant experiences into the more extensive dynamics of the solar system. It shows how the presence and position of every planet can have sweeping impacts, affecting the solidness and direction of different bodies inside the framework. So, for what reason are conspicuous astrophysicists just now raising worries about a possible accident between Pluto and Neptune? Notwithstanding every one of these complex powers attempting to forestall such an event from happening, Neil deGrasse Tyson, a renowned astrophysicist, offers a novel viewpoint on the secrets of our nearby planet group, especially the enrapturing instance of Pluto. Tyson, known for his part in the renaming of Pluto from a planet to a bantam planet, offers sagacious analysis on the developing nature of divine mechanics and the public's fascination with the neglected compasses of room. Tyson's situation on Pluto's renaming is established in the ever-expanding information on our nearby planet group. He considers the renaming to be not a minimization, but instead a fundamental change in accordance with our developing comprehension of the many bodies circling our Sun. Tyson's way to deal with heavenly mechanics is one of constant learning and adaptation. He sees the complexities of Pluto's circle, as well as its interactions with Neptune, through a lens that perceives the capriciousness of space. He suggests that while Pluto's circle is steady for now, it could go through significant movements later on. This chance fills in as an indication of the amount we still need to find about the powers shaping our nearby planet. All in all, Pluto's circle is a captivating contextual investigation of the complex interchange of gravitational powers in the solar system. While its way is steady now, the perplexing dynamics between Pluto, Neptune, and the different planets imply that even the most apparently steady circles could change over time. As astrophysicists like Neil deGrasse Tyson continue to investigate the mysteries of the universe, they help us better grasp the sensitive equilibrium that governs the movements of heavenly bodies. The potential for a Pluto-Neptune crash isn't necessarily inevitable. Be that as it may, it's an indication of the continually advancing and unusual nature of the universe. Notwithstanding the logical speculations surrounding Pluto's circle, it's essential to consider the more extensive ramifications of these dynamics for our understanding of the nearby planet group and the universe at large. While Pluto's venture is one of interest, it's also a reminder that the universe is brimming with secret intricacies standing by to be investigated. The idea of orbital reverberation, especially between Pluto and Neptune, is a critical piece of the puzzle. This reverberation, where the proportion of Pluto and Neptune circles is 2 to 3, is a noteworthy component of heavenly mechanics. For each 2 circles Pluto finishes around the Sun, Neptune finishes 3. This proportion ensures that despite the fact that the circles cross, the 2 planets never impact. This is a result of the gravitational interactions that stabilize their ways, working in tandem to forestall any disastrous impact. The significance of reverberation in maintaining vast stability couldn't be more significant. It gives an illustration of how frameworks in space, even those that at first show up tumultuous, can self-direct through unobtrusive gravitational forces. Figuring out this reverberation additionally explains why Pluto, notwithstanding its capricious circle, has stayed stable over billions of years. This peculiarity is a fundamental viewpoint of the nearby planet group's larger architecture. The impacts of planets like Jupiter, Saturn, and even Uranus are vital in maintaining stability in the circles of smaller bodies like Pluto. Jupiter, with its monstrous gravitational force, acts as a sort of defender for the inner planetary group, affecting the directions of different space rocks and other bantam planets, including Pluto. In reality, some scientists conjecture that Jupiter's gravity might have prevented Pluto from being catapulted from the solar system completely. Without the defensive impact of Jupiter, Pluto's circle may have been disrupted far more, possibly sending it out of the Sun's gravitational influence.